In this video, we're going to look at solutions, and specifically we're going to look at water because a lot of reactions in chemistry happen in water. Now, just some definitions. If you mix two substances together, like salt and water, you get what's called a solution. The majority component, in this case water, would be your solvent, and the minority, this case the salt, is your solute. And an aqueous solution, if you ever hear that, and you will in this class, is where water is your solvent, or that's your majority component. Now when we talk about solutions, we can have two types. One, the solution can be dilute, where you only have a lot of solute to your solvent, or it can be concentrated. You can have a lot of solute to your solvent. And there's not really numbers to go with this. There's no hard cutoff to say if something is dilute or something is concentrated. It's more of a way to compare the two things. You would say something is more dilute than something else, or something is more concentrated than something else. And when we talk about solutions, the unit we use is the molarity, capital M. And you'll see this unit a lot. And molarity is the amount of solute in moles divided by the volume of solution in liters. So molarity, big M, moles divided by liters. So here's a question for you to get used to the idea of molarity. So what's the molarity of a solution if we add 45.4 grams of sodium nitrate, NaNO3, and we dissolve it in water to create a total volume of 2.5 liters? And so remember, molarity, M, moles divided by liters. So take a minute, try to solve that, come back when you have an answer. Alright, let's look how to solve this. Like a lot of the problems we have been doing, this is just strictly dimensional analysis. So we start with 55.4 grams of sodium nitrate. And we say we want to dissolve it in 2.50 liters. So right now we have grams divided by liters, but we want moles divided by liters. So we have to change this number into moles of sodium nitrate. And we do that by molar mass. And we figure out from the periodic table there's 84.99 grams of sodium nitrate per 1 mole of sodium nitrate. Now our units are moles divided by liters, so we're good to go to calculate. And our answer is 0.214 molal. That is usually how you say molal or molar. Now one equation you're going to use a lot, especially in lab, is the dilution equation. And it's M1V1 equals M2V2. So let's say you have one solution and you want to dilute it, make it less concentrated to a certain molarity. You want to use this equation where M1 is molarity of solution 1, V1 is volume of solution 1, M2 is molarity of solution 2, and V2 is volume of solution 2. So let's see how we use the dilution equation. So to what volume in milliliters should you dilute 100 milliliters of 5 molar calcium chloride to obtain 0.750 molar calcium chloride? So you're going to want to use the dilution equation and try to figure this out, take a stab at it, and come back when you have an answer. Alright, let's take a look how we solve this. First, we have to decide what is M1, V1, M2, and V2. It really doesn't matter as long as you're consistent. So I'm going to say calcium chloride, M1, molarity is 5. Therefore, I already know the volume is 100 milliliters. M2, since has to be our second solution, since this was our first solution. M2 is 0.750. V2 is our unknown. So we have one equation, one unknown, and we can solve. So 5 molar or moles per liter multiplied by 0.1 liter. So this is 100 milliliters, and we know there's 1,000 milliliters in 1 liter. So that's why I'm using 0.1 liter here. That's equal to 0.750 moles per liter multiplied by X. So I want to solve for x. So I'm going to multiply these two numbers together, divide by 0.750 to get x. When we do that, we get x is 0.667 liters, or 667 milliliters. That is what we want to dilute our solution to take it from 5 molar to 0.750 molar. Now, we already talked about stoichiometry, and we can use stoichiometry for solutions. And we can use stoichiometry for mixing two aqueous solution. And we can also determine limiting reagents, and we can also determine theoretical yield all through solutions using the principles we've talked about in previous videos. So here's an example problem. So what volume in milliliters of a 0.150 molar HNO3 solution will completely react with 35.7 milliliters of a 0.108 molar Na2CO3 solution, according to this equation? So take a minute and see if you can solve this. Again, I know this is getting more and more difficult, but it's just dimensional analysis over and over again. So try and solve this, pause the video, come back when you have an answer. Alright, let's take a look how we do this. So dimensional analysis, let's get our train tracks. I'm going to start with 0.108 moles of sodium carbonate, because we're saying how many mils of HNO3 do we need? So this is what we want to find, and this sodium carbonate is what we know already, so that's why I'm starting with that. And this is 0.108 moles per 1 liter, because this is molar. Now I'm going to convert this into milliliters, because our final answer should be in milliliters, so I'm just going to already convert that to milliliters. And we have 35.7 milliliters of this solution. So we don't have 1 liter, so I have to account for that. So in total we have 35.7 milliliters. And this is the beauty of this train track method. Let's look at our units. We've got liters, liters, cancel out. Milliliters, milliliters, cancel out. So right now our units are moles of sodium carbonate. And we want to get the HNO3, and the only way to convert Na2CO3 to HNO3 is by moles using stoichiometry. So by doing this calculation, I figured out in our 35.7 milliliter sample of sodium carbonate, I have 3.86 times 10 to the minus 3 moles of sodium carbonate. Now let's go to nitric acid, HNO3. So we're going to start with the number of moles, and we know from stoichiometry 1 mole of Na2CO3 is equal to 2 moles at HNO3. Now our final answer needs to be in a volume. So we're going to use our molarity, because molarity is moles divided by liters. And we can say our actual sample is 0.150 moles HNO3 per 1,000 milliliters. Now big M is actually moles divided by liters, but I did the conversion already, and I just said instead of 1 liter, I'm going to save myself a step and just say that's 1,000 milliliters. If you're not comfortable with that yet, feel free to write 1 liter and then go to milliliters. You'll get the same answer. But right now our answer is in milliliters of HNO3. That's what we want. That's what the question is asking for, so we're good to calculate. And we get that to react completely with this amount of sodium carbonate, we needed 51.4 milliliters of HNO3. Again, I know that problem seemed hard, but it's just dimensional analysis over and over and over again. Alright, that's it for this video. See you in the next one.